Hello, I'm Tim Bramble, the product manager for ArcSight's behavioral analytics solution, ArcSight Intelligence. I'm joined today by Tushar Imam, who is a security operations sales specialist. In this session, we'll discuss why an unsupervised machine learning approach, such as that used by ArcSight Intelligence, is uniquely able to detect insider threats and how to optimize the data it monitors for best possible coverage. I'll start with an overview of ArcSight Intelligence, how it works, and why we believe its unsupervised machine learning approach is the most effective way to detect insider threats. Tushar will then present an approach one of our customers followed to identify gaps in their current cyber detection coverage, and how they address them with ArcSight Intelligence by identifying the data that would provide them the necessary insight. From there, we'll explore some guidelines for determining data quality and illustrate how ArcSight Intelligence ingests and normalizes data. We'll then examine some data science myths and present an approach for selecting the sources of data that will provide optimal coverage for the use cases you wish to detect. We'll wrap up with some tips for getting the most out of the data you've selected. Let's take a few minutes now to introduce ArcSight Intelligence and how it uses unsupervised machine learning to provide vital insight into insider threats. ArcSight Intelligence allows you to distill billions of log events into thousands of instances of unusual behavior, or anomalies, and surface the riskiest actors in your organization, be they users, machines, servers, domains, websites, or other entities. In other words, intelligence provides a handful of high-quality threat leads from which you can begin your investigations. This allows you to move beyond worrying about what you might be missing and instead focus on the threats that matter most. Traditional security applications concentrate on finding threats using rules and thresholds or pattern matching. These are excellent techniques for finding known threats, but they don't work so well for catching evasive and evolving insider threats. Or said another way, you can't write a rule for an unknown threat. ArcSight Intelligence uses unsupervised machine learning to detect anomalous behaviors that help indicate the threats. It does this by creating unique normals or baselines for every individual entity it observes and flagging behavior outside the norms as anomalies. It then assesses the anomalies and applies and adjusts a unique risk score for each entity involved. These risk scores are normalized to a simple value between 0 and 100 to make it easy to compare relative risk. We have hundreds of person-years and deep data science and cybersecurity expertise invested in this approach. Unsupervised machine learning establishes unique normal behavioral baselines without the need to label data and train models associated with supervised machine learning techniques. Because ArcSight Intelligence's models are trained automatically and continuously based on the data it sees, it can adapt to changing circumstances automatically and with no administrator intervention. For example, when COVID-19 hit, the new norm for many companies was for employees to work from home. In the weeks that followed, analysts were flooded with false positives as employees accessed company resources over VPN during working hours from new locations, things that would have been red flags prior to the pandemic. Whereas the rules and thresholds configured for these systems needed to be updated, a process involving tremendous effort, ArcSight Intelligence adapted to and established new baselines within days, automatically and without the need for any intervention. Consider this list of activities. Without context, it's very difficult to determine whether these are malicious or benign. It's practically impossible to write rules or set thresholds to reliably detect insider threats. ArcSight Intelligence surfaces instances of unusual behaviors anomaly alerts. These alerts identify the entity involved, in this case the user John, the activity, for example, copying an unusually large amount of data compared with other sysadmins, the relevant asset, for example, sensitive files, and a method, if applicable, using a USB drive, for instance. These anomaly instances are scored for risk and affect the risk score assigned to each entity. Consider an example in which Anne is observed to be active at 3 a.m. This is not by itself an indicator that anything is amiss, but it is unusual for Anne, who typically works between 8:30 a.m. and 6:30 p.m. on weekdays. Anne's risk score is therefore elevated to 15, which is still considered low risk. and then connects over a VPN from China, checks out an unusually large number of files from a code repository that neither she nor her peers typically access, and posts a significantly larger amount of data to a website than is usual for her. None of these behaviors taken in isolation is necessarily a cause for concern. Rules that flag these individual behaviors would generate a large volume of false positives. But taken together, these behaviors are enough to elevate Anne's risk score to 96, prompting security teams to investigate this potential instance of data exfiltration and any other activity in which Anne was involved. Now that I've introduced ArcSight Intelligence, I'll hand off to Tushar, who will take the next few minutes to provide a real-life example of a customer's journey to develop an insider threat program tailored to their unique circumstances.
Thank you, Tim. My name is Tushar Imam. I'm a Security Operations Sales Specialist. I'll be reviewing for you a real-world example of ArcSight Intelligence. The genesis of this project was that a Chief Operating Officer asked the simple question, what do we have, where is it, and who touches it? IT and security couldn't come back to him with a robust enough response, and so he decided that what needed to be implemented was an insider threat program. The challenges of such a program are the billions of events that they would need to inspect. And so they reverted to existing manual processes, specifically 2 engineers, half a week each, examining emails being exfiltrated from the organization to see if anything was sensitive. However, this leaves security gaps such as web exfiltration through Google Cloud and Dropbox, and nothing really sophisticated was being detected, such as pass-the-hash exploits and detection of disk partitioning. In constructing their insider threat program, they took a multi-phase approach, firstly looking at the attack vectors which they wanted to be able to detect via the MITRE ATT&CK framework. Secondly, reviewing all the available log sources that were available for running analytics. Thirdly, determining that CrowdStrike Falcon EDR data was already available and the most rich in terms of telemetry. They clicked the try free trial button on the Falcon Cloud marketplace and frictionlessly installed our service, importing the data from Falcon Cloud without the need to implement anything on their infrastructure. The Falcon Cloud sent the data to ArcSight Intelligence, which is an unsupervised machine learning engine, which is augmented with human-based threat hunting experts. Thus, they were able to leverage the existing telemetry from the EDR data and also repositories and AD, and were to give a dramatic improvement in the insider threat program against the MITRE ATT&CK coverage. When the solution was implemented, a dramatic result was shown in terms of findings by our threat hunting team. These included reconnaissance, such as financial advisors running reconnaissance executables within the infrastructure, multiple queries of Active Directory for usernames and searches for the files that shared that same username, and unbelievably 732 attempts at password guessing across the C-suite, guest accounts, auditors, security scanning accounts, local administration accounts, and machine accounts. In terms of sensitive data which was being accessed, this included internal exchange rates, which is very dangerous for a financial services organization in terms of insider trading, internal rebranding collateral, which was not public information, multiple passwords were being stored as clear text files, and unusual processes. These included encrypted messaging app Telegram, which is specifically barred by Financial Conduct Authority regulated organizations. The customer was also very gratified that their own red team activities were being detected by the service. These included DLL injection, pass-the-hash attacks, scanning attacks, and log4j attacks. And that's the end of the real-world example. Handing back to you, Tim.
Thanks, Tushar. I think this is a great example of selecting the right data sources to gain visibility into otherwise undetected threats specific to the customer's environment. Let's now take a look at some considerations for assessing the quality of a given data source. As the expression goes, garbage in, garbage out. So it's very important to have high quality data as the foundation for the analytics you employ to detect insider threats. The first consideration is whether the data contains the behaviors you hope to detect and whether analytics will actually expose them. For example, you won't be able to detect source code theft effectively without any visibility into who has access to the repositories containing it. Conversely, there'd be very little point in feeding daily weather conditions into ArcSight Intelligence, as this information is irrelevant to the analytics it performs. Next, it's important that the event data analyzed is valid. This includes ensuring that the values assigned to the events field actually reflect the intent of what the fields are meant to capture. For example, it's crucial that timestamps reflect when an event occurred versus when that event was processed by a downstream system, which may be seconds, minutes, or even hours later. We've also encountered examples in which event field values seem impossible, such as a negative value for the number of bytes transferred. In this case, this may have been the result of an integer overflow owing to a very large amount of data transferred. As ArcSight Intelligence baselines what is normal for an entity, it's vital that all actions are attributable to a consistent representation of that entity. Depending on the systems I use, I may be represented as Bramble, all lowercase, Bramble in mixed case, or tim.bramble@microfocus.com. To profile my behaviors effectively, analytics needs to consider all events related to me rather than develop separate baselines for each variation of my identity. Whereas inconsistency is an acute challenge for entity IDs, it's also problematic for other fields. There's nothing inherently wrong with representing locations by city name, for example, New York, but field name destination geolatitude suggests that other values stored in this field will be numeric latitudes. Beside the obvious issues with data that has been tampered with, integrity refers to ensuring that data provides a complete, non-duplicative account of what's happened. Filtering out events for specific entities or of a given type leads to an incomplete picture of what has occurred, and therefore less meaningful analytical results. And last but not least, it's important that data is accurate. Timestamps rounded to the nearest hour and imprecise locations are examples of data lacking the resolution to yield effective insights. The ArcSight Intelligence data ingest pipeline offers opportunities to address some of the data quality issues I just outlined. Typically, ArcSight smart connectors and flex connectors parse data from a broad set of devices. This helps ensure that the information is mapped consistently to appropriate fields in a common event schema. Some basic entity ID resolution can be performed by the connector parsers, for example, converting all IDs to lowercase. The ArcSight Intelligence normalization processes perform more involved entity ID resolution, for example, by inferring equivalency for IDs of different formats representing the same entity. Normalizers are also used to make other fields more consistent and can be used to enrich a subset of the fields. Generally, normalizers are there to format the data to improve analytical outcomes. The analytics stage is where ArcSight Intelligence employs unsupervised machine learning to baseline entity behaviors and identify instances of behavior falling outside established norms. In other words, generate anomaly alerts. This includes building a list of entity relationships, aggregating behaviors into bucketed counts on a minutely, hourly, and daily basis, and ongoing analytical model training. The analytics stage is also responsible for scoring each anomaly alert in terms of how unusual it is. The risk engine is responsible for updating entity risk profiles with normalized risk scores between 0 and 100 based on the weighted impact of the anomalies observed. It can also take into account alerts of suspicious behavior from third-party systems. Such alerts are unsuitable for unsupervised machine learning because they only identify anomalous behavior. It is impossible for ArcSight Intelligence to determine normal behavior from these alerts, but they can be used to influence the risk score assigned to the entities involved. Okay, so armed with a better understanding of what constitutes high-quality data for analytics and the ways in which ArcSight Intelligence processes and optimizes the data, let's examine how to apply a use case-driven approach for data source selection. Before proceeding, it's useful to dispel some myths when it comes to data science behind behavioral analytics. The first is that analyzing data from a greater number of sources necessarily improves the results. This is not generally true. As we'll see in a few minutes, achieving breadth and depth of use cases detected by the data sources is important. However, data quality is more important for good results. Adding poor quality or less relevant data to otherwise high quality data sets adds noise that it can obscure the more useful findings. Duplication of behaviors reported resulting from overlapping data sources can present challenges as well. Also, the greater the number of data sources ingested, the more likely it becomes that different representations of entities will exist, making it difficult to normalize them into consistent identifiers. We found that logs from authentication, access, web proxy, remote access, and source code repository systems can yield good results. Endpoint telemetry also typically provides incredibly rich insight into the behaviors used to detect insider threats, and is often the only source required to yield effective analytics. This was the case for the customer Tushar described earlier. As we'll see in a few slides, Active Directory alone can be used to detect several cases of classes of anomalies if configured appropriately. But all things being equal, we'd like to be able to concentrate on the data itself rather than the device logs from which it came. Another myth is that to be effective, analytics must catch all occurrences of any possible aberrant behavior. Detection of unknown threats usually involves not only the observation of multiple events, but the combined effect of multiple instances of anomalous behavior. The anomalies that ArcSight Intelligence flags are based on years of cybersecurity and data science expertise, and they expose specific behaviors. These behaviors in aggregate provide initial indicators of threat in action, as illustrated by the Ann Funderburk example I presented earlier. While I hope I've demonstrated the clear benefits of applying unsupervised machine learning techniques to big data, such analytics are quite resource intensive. It's therefore desirable to concentrate on the data that will yield the best results. By focusing on those high-quality data sources, ArcSight Intelligence can be allowed to create insightful threat leads by aggregating instances of anomalous behavior into easily understood entity risk scores. Throwing other data in the mix simply for the sake of completeness can lead to noise that obscures otherwise actionable results. Okay, so having dispelled these myths, let's now explore how to determine what data will provide you greater insights into the use cases you're concerned about. The first step is identifying the use cases of concern for your organization. If you're a healthcare provider, you are likely most concerned about inappropriate access to patient records. Depending on other controls, you may or may not be as concerned about the opportunity for patient records to be modified. But inappropriate access can be a violation of patient privacy, and identifying this is of paramount importance. If you work for a high-tech company, theft of intellectual property is likely a top concern. Losing IP can put you at a competitive disadvantage and even threaten your company's existence. It will therefore be important to monitor your assets in source code repositories, for example, and any attempts to exfiltrate this data. Similar to healthcare, in the world of finance, you're likely concerned about inappropriate access to financial systems. However, your focus is likely to be on the ability to affect transactions as well as who has access to financial data. And depending on the department, if you work for the government, you may be concerned about data exfiltration and/or the ability to access and compromise critical infrastructure. Understanding your use cases of concern can help you identify the data sources you need to monitor and the behavioral indicators that will be exposed to identify threats. The MITRE ATT&CK framework offers a very convenient way to identify areas of concern and any gaps you may have in covering them. Earlier in this session, you'll recall that Tushar discussed a customer who used the framework to understand their current gaps in detecting insider threats. With our help, they were able to use the framework to see that ArcSight Intelligence would be able to identify their use cases of concern by monitoring CrowdStrike endpoint telemetry. According to MITRE, the framework is a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. It is used as a foundation for the development of specific threat models and methodologies in private sector, in government, and in security product and service community. The enterprise version of the framework consists of techniques and sub-techniques grouped under 14 different tactics. Each tactic represents the why of an attack technique or sub-technique. It's the adversary's tactical goal, the reason for performing an action. For example, an adversary may want to achieve credential access. Techniques represent how an adversary achieves a tactical goal by performing an action. For example, an adversary may dump credentials to achieve credential access. Once you have a sense of the MITRE attack techniques of concern, you can consult the ArcSight Intelligence Coverage Guide. It lists all the techniques that intelligence has a role in detecting. For each technique, the guide lists the type of data that are generally required and the corresponding behavioral indicators that intelligence will flag, as well as the number of anomaly types involved. Based on an analysis of your data, we can also generate a coverage guide that is tailored to your specific data sources. It's important to note that certain data sources are richer than others. Some data sources can expose a variety of different types of anomalous behavior. For example, Active Directory, if configured appropriately, can cover authentication, access to shares and resources, and remote access use cases. Endpoint telemetry can reveal what was accessed by which account using which process in which location, be it file share or drive. In addition, EDR data can cover some network activity. Other data sources have a more singular focus. For example, VPN logs only reveal remote accesses. Repository logs only reveal what was accessed, how, and by whom, but they typically do not indicate which processes access the data. Web proxy logs only reveal the nature of the web data transfer or communications. They often do not provide any direct indication of who is performing the transfer. This is not to suggest that value can't be derived from less rich data sources. They can be used to expose behaviors not observable in the richer sources. As an example of data source richness, consider this chart of the most typical use cases detected by ArcSight Intelligence and the number of anomaly types associated with each use case. Common use cases are generally detectable in all data sources. For example, unusual working hour anomalies can be detected in any data source with a timestamp. Logs from certain systems can surface multiple types of use cases. You can see that with Active Directory data, for example, can be used to detect most of the anomaly types associated with the common access and authentication cases, and several associated with remote access. Looked at in terms of the MITRE attack framework, the techniques highlighted in blue are detectable with sample Active Directory data that we analyzed. Some of the same techniques and a number of other techniques are observable with the sample web proxy data we analyzed, as indicated in green. And the orange techniques are the ones that could be detected with sample code repository data we analyzed. Remember the example of how ArcSight Intelligence aggregates behaviors when assessing entity risk? I've annotated it with the types of data sources used to detect each anomaly. To detect this vector of source code theft, it's necessary to look at logs from Active Directory, the VPN, the code repository, and the web proxy system. Endpoint telemetry, on the other hand, may have been enough to expose each of these anomalies and also cover data exfiltration via USB drive, for example, rather than through posting to a website. Ideally, you'd like all entity behavior to be baselined. Although this isn't necessarily possible, combining data sources can provide better coverage. It's important to consider two dimensions when assessing how to achieve the best possible coverage of use cases. First, you'll want to ensure you can detect the broadest set of use cases possible. For example, the maximum number of MITRE attack techniques. This involves selecting data sources that are complementary from a coverage perspective. But you should also ensure that you're covering the use cases in depth. For example, if half your employees use one VPN system for remote access, while the other half uses another, you may want to monitor both to ensure you have all employees covered. Or, if you are concerned about data exfiltration, you may want to monitor multiple ways in which attackers can transfer data outside your organization. But I'd be remiss if I didn't reiterate some caveats with analyzing data from multiple sources. First, it's vital that the multiple forms of entity IDs are normalized to a common ID so that we can attribute all observed behaviors to the user who exhibited them, for example. And second, data quality is very important. Remember, garbage in, garbage out. Let's take another look at the MITRE attack coverage possible with the sample data sets we analyzed, starting again with Active Directory. Adding the sample web proxy data to the mix, it's apparent that we've broadened the number of techniques that should be possible to cover. Whereas adding our sample repository data to the mix doesn't appear to have much benefit beyond exposing an additional technique, it's worth remembering that both the web proxy and repository data serve to provide deeper coverage of the techniques exposed by both of them and Active Directory. And this diagram of the coverage afforded by CrowdStrike data illustrates that endpoint telemetry can certainly be enough to surface many techniques all by itself. Wrapping up, here's some tips for maximizing your data based on situations we often encounter with customers. First, ensure that you configure your systems to emit all events upon which ArcSight Intelligence analytics rely. There are a specific set of Windows event codes, subcodes, and login types, for example, required to provide the best possible coverage in Active Directory data. Second, collect logs from the greatest set of machines possible. For example, monitoring domain controllers only is less effective than also monitoring all member servers and machines. Third, it's best to provide a full view of all entities contained in the event logs. We sometimes encounter situations where, for example, hidden accounts ending in $sign are filtered, but hackers often use these. Thanks for attending this session. If you'd like to learn more about ArcSight Intelligence, visit our website and consider requesting a demo.